Hey, what's going on, guys? In this video we are going to see how to represent signed integer using ones complement representation. Ones complement representation is nothing but the reverse of all bits. For example, let's look at an example. Let's say we were asked to store plus 7 in an 8-bit memory location. Store plus 7 in 8-bit memory location. Here what we have to do is, first we had to write the binary coded decimal for 7. That is not actually convert this as 7 into decimal place, binary. If you convert 7 into binary, you know that in binary it goes like 1, 2, 4, 8, 16, 32 like that. If it's 7, it's going to be 1 here, 1 here, 1 here, and we had to fill others with 0. But previously, if you watch my previous video, in that one we did sign and magnitude. There what we did is we do n-1, like if it's an 8-bit we do n-1 and fill up, we see how many numbers we have and we fill up the rest of them. Like if it's 8-bit, if we have 3 gone, we fill 7 first, then based on the sign we put the leftmost integer, like whether if it's positive it is 0, if it's negative it's 1. But for ones complement representation it's different. The difference is here we just fill the whole 8. We don't even think about the sign first. So here, without even looking at positive or negative, I'm just going to fill 8 numbers. Here we have 3 gone, so we had to put 5 more zeros. 5 more zeros. Now if it's positive we just leave it as it is, no action needed. But if it's negative, what we do is we take the ones complement. That's the difference. For the sign and magnitude, if you watch my previous video, we can also represent these sign integers in sign and magnitude. There what we do is we fill until this, and based on the last integer, based on the sign, we decide the last integer, the leftmost integer. But for this one we don't even have to do that. If it's negative, we had to do the ones complement for this one. Okay, now let's look at a negative number so we can see it clearly. Let's say we have asked to store negative 258 in a 16 memory location, in a 16-bit memory location. First of all, we have to write the binary for this 258. Now let's convert this 258 into binary. We know that one binary goes like 1, 2, 4, 8, 16, 32, 64, 128 and 256. In order to get 258, we had to have a 256 and a 2. Others are going to be just 0. 0, 0, 0, 0, 0, 0, 0. Now how many numbers we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Alexa, what is 16 minus 9?
16 minus 9 equals 7.
So we had to put 7 more zeros in front of this. We don't even have to consider about the sign right now. We just have to put 7 more zeros in front of this. So let's put 7 zeros first. 1, 2, 3, 4, 5, 6, 7. And after that we fill it up with this number. 1, 0, 0, 0, 0, 0, 0, 1, 0. Okay, then we do the ones complement. Ones complement is exactly opposite of what we have right here. So let's do the ones complement. If you do the ones complement, this is going to be 1, 1, 1, 1, 1, 1, 1, then 0, 1, 1, 1, 1, and after that 1, 1, 0, 1. And this is the ones complement of this number. This is 258 and this one is negative 258. And that's how we can store negative 258 in 16-bit memory location. And that's how we do that. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn digital logic design or computer architecture, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.